Okay, so for part 2 of this lab, you're now going to introduce them to some species that they may not have ever thought about. These are not the sensational species that we always think about when we talk about climate change or global warming or extinctions, but these are very important species to the ecosystems in which they live. And you might bring them back to the isotopes lab when you guys talked about how you make these food webs and they're very complex and each level is depending on the other level, and removing one species could be devastating to the food web. And so these are integral species in the food webs here in our area here in Utah in the Southwest. All right, and that's important too. We're going to look at it at our area. So here's some of the species that are these are the 5 species we're going to look at, and they've got information there on the slide. You're welcome to do your own research on this and show them a cute video or whatever. You want to get them interested in these animals. All right, so we've got the American pika. We're going to talk about the desert tortoise. There's some really interesting things about the desert tortoise. They live for a very long time. They can go a very long time without water. Red brome is a grass that grows only in certain areas in the West. The Joshua tree that's nearly extinct, so this is a really important one to talk about and a really cool species. And then the bristlecone pine, which is also a fairly rare species and a really neat plant. So if you want, like I said, if you want to look up some stuff and make them really sensational, make the kids really care about them, that would be a really good idea. So you're going to introduce them to these species, and then their job is to build a climate envelope. All right, so I'm going to show you how this is done. We'll just do it with red brome, and then you can see once you've done it with red brome, you should be able to do it with all of the other ones. And let's see, I'm going to get to my map. Okay, so in their student guide, let me see if I can bring this around, flip it down. Okay, so you should have, in their student guide, they have each of these maps for the different species. And what they're going to do, is they're going to look at their species. So they should have these 3 maps out on their table. So they have the temperature map, they have the precipitation map, and then they have the climate the species distribution. All right, so we're looking at red brome, and each of these little green dots indicates where we see red brome. So what we're looking for is the highest temperature and the lowest temperature at which red brome will exist, so that we can get a range, a window on our x-axis. All right, so if you look at red brome, you can see that the highest temperatures, you can see some up here in Washington, right? There's 2 up there, there's 1 in Idaho, and we don't have Washington on the map, but we do have this one in Idaho, but it looks like this one in Idaho looks like it's in this green area right here, okay? And same thing in California, they go up the north, but you see they're bristled at the same place as these green areas in California, and it's really, as far as I can tell, even in Utah, the places where we see it are in the green rather than in any blue. And so that's something to pay attention to, that it appears that it only gets into green temperatures. So if we look at the temperatures, that means maybe 62 to 65 degrees is the lowest it can go. So we're going to go onto our map and say, all right, so of our temperatures, 62 to 65 degrees is about the lowest point for red brome, all right? So I'm just putting that on there. And then let's look at the highest. Where is it the warmest? Now we don't have these dots that are down here in Mexico. We don't have them on our temperature map. But using that site in the instructor guide, they can actually go online and explore the whole globe. So if they wanted to go in and look at Mexico and what these temperatures are actually down here, that might not be a bad idea, but they can stick with what's on the map. So we see it very, very much clustered here in Arizona and in Southern California. So we're getting into these dark browns. So that's 88 to 92. So I would say that the highest temperature red brome occurs at is 92. All right, so we know that it's going to be somewhere in that range on the x-axis. But now the y-axis is precipitation. So we have to look at, when it's in these really hot areas, is it restricted to some precipitation range? Okay, so if we look at our precipitation map, which is this one, you can see that it's clustered kind of all over in Arizona. So looking here, we get into some of the green. It looks like the green does not restrict it, okay? It looks like even these dark red, it looks like we don't have any in this corner of Arizona. We don't have a ton of the red brome. It looks like when it gets into that dark red, they sort of shy away from that dark red. You can see even here like a little gap in the Southern California that's sort of, so sorry, let's see, this gap right here in their distribution that sort of mirrors this where it gets into that really dark, and same thing, this lac right in here that, oh, why am I showing you? The lac right in here that you're seeing also sort of mirrors this dark. So I would say that they don't tolerate well the dark areas. So maybe we jump up to here. So 4 to 8 inches is looks like what they can handle. So here, the lowest range, 4 to 8 inches. And what is this? Average annual precipitation in inches. So they can go way down to the very bottom. All right, 4 to 8 inches. They're way down here. All right, so at that really high temperature, okay, they're down here at 4 to 8 inches. All right, so we're going to put a dot right there. So they can get up to 92, but it has to have 4 to 8 inches of precipitation. Okay. At this low temperature, when it was, oh, let's look at, do we have any? We don't. That's the lowest. Okay. What's the highest precipitation that they thrive at? Well, we can look at our high precipitation areas on this map. Whoops, bringing it down. All right. So if we get into any of the blues, do we see brome where it gets into blue? And it looks like we don't necessarily see the red brome when it gets into blue. Okay, it looks like it may be the light blue, but not that dark blue. So the light blue might be the edge of the precipitation. So that's that 50 to 60 inches. So maybe right in here, 50 to 60 is about the high range right there. Okay, so in those 50 to 60, let's look on our temperature map. What was the temperature? 50 to 60 looks like it was around 70-ish degrees, okay? So at 70-ish degrees, when it was down in that cold, let's look at that cold, when it was down at the 64, so up even farther north, even in Idaho, that dark green, let's look at that Idaho spot. The Idaho spot is actually fairly dry, so we're not going to have when it's that cold, it's a little bit higher, or I'm sorry, it's a little bit lower precipitation, okay? But if we raise the precipitation, it has to be warmer. What am I doing here? So at the 60 degrees, when it's like 64 degrees, it's actually fairly high precipitation, or just fairly low precipitation, 8 to 12. So we have a dot maybe right here. But it can be at that temperature. Can it be at that temperature? At any higher precipitation, it doesn't look like it. It looks like when it's over here, the temperature is more like 70-ish degrees. So we end up like this. Now at 90 degrees, when it's 90 degrees, it can go down to this very low, but is there any place where it's warm but it has high precipitation? Let's see, so we're looking at our map. Hold on one second.